All right, guys, in this video, we're going to talk about the quadratic formula. Specifically, we're going to talk about the discriminant, okay? So the quadratic formula, you can see here, it's x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac divided by 2a, okay? This a, b, and c values comes from the quadratic here when it's written in standard form, okay? Notice a can't be 0. If a is 0, you don't have an x squared term, so it ceases to be a quadratic equation, okay? In this video, though, we're going to focus on the discriminant, and the discriminant is this part underneath the radical, okay? So the discriminant is the part of the quadratic formula that is underneath the radical, okay? It's b squared minus 4ac, all right? Now, the discriminant is going to help us determine the number and the nature of the solutions that each quadratic equation will have, okay? So we're going to find what the value of this discriminant is, and that's going to tell us how many solutions there are and what type of solutions there are, okay? So if the discriminant is positive, okay, so when you do b squared minus 4ac, if you get a positive number, there's going to be two real solutions, okay? Those real solutions could be rational, they could be irrational. If the discriminant's a perfect square, you're going to have rational solutions. If the discriminant is positive, but it's not a perfect square, okay, then those solutions are going to be irrational, all right? If the discriminant is 0, there's going to be one real solution, okay, and it's forced to be rational because you're going to have the fraction negative b divided by 2a, which has to be a rational number, all right? And then finally, the discriminant could be negative. If the discriminant is negative, all right, we're going to have a negative value underneath the radical. That means we're going to have two complex or two imaginary solutions, okay? So the discriminant tells us how many solutions we have. It's either going to be 2 or 1, okay? And whether or not they're real or imaginary, okay? So I've got 3 examples here, A, B, and C. Let's do A together and then pause the video and you can try B and C and then come back and check your work, okay? So notice all 3 of these are already written in standard form. We've got the quadratic trinomial on one side set equal to 0. All right, so we can label in part A is going to be 1. There's an understood 1 in front of x squared. B is negative 4. And C is positive 4, okay? So we're going to take these 3 values and we're going to plug them into the discriminant, b squared minus 4ac, okay? So when we do that, I replace b with negative 4. Make sure to use parentheses here because when you square this negative 4, you should get a positive 16. If you don't have the parentheses there, you're going to get a negative 16, and you should know that's incorrect, okay? Minus 4 times a, which was 1, times c, which was 4, okay? So when I complete that, I get 16. Negative 4 squared is positive 16. Minus 4 times 1 times 4, well, that's going to be 16. So my discriminant is 0, okay? So that puts us in part B here. There's going to be one real solution, okay? Because the discriminant is 0. All right? Okay, let's look at B. Pause the video here, give B and C a try, and then come back and check your work. All right, x squared plus 5x plus 10 already in standard form, so my A value is 1, B value is 5, C value is 10. Okay, so let's plug these 3 values into my discriminant, b squared minus 4ac. And I get 5 squared minus 4 times 1 times 10, okay? Let's do the math out. That gives me 25 minus 40, which means my discriminant is negative 15, okay? So that puts me in choice C here. I've got a negative discriminant. That means I'm going to have 2 complex or 2 imaginary solutions, okay? There are going to be 2 complex solutions for that quadratic equation, all right? And then in C, notice you could, we've been factoring some recently, you could factor out a 2, but it doesn't matter. If you take out a 2, if you leave it like this, it doesn't matter. Your discriminant's not going to change its nature. It's not going to change from positive to negative, okay? It just might be a little bit different, okay? The number would be different. But let's go ahead and use the numbers as they show up here. So A is 2, B is negative 12, C is negative 4. Let's plug those into our discriminant, b squared minus 4 times a times c, okay? Make sure, again, if b is negative, you put that in parentheses so you ensure that you get a positive value when you square that. So it's going to be 144 plus 112. 4 times 2 times 14 is 112, okay? And we got a negative times a positive times a negative. So that 112 is positive, okay? So that gives me 256 as my discriminant. That's a positive number, so we're up here in part A. That means I'm gonna have two real solutions, okay? Because 256 is a perfect square, all right, 16 times 16 is 256. That means my solutions would be rational. If this was 257, for example, then my solutions would be irrational because 257 is not a perfect square, okay? So that's how you use the discriminant to tell the number and the nature of the solutions of any quadratic equation.